All right, so good morning or afternoon, maybe in Florida. I'm Dr. Christy Mulkey, and I'm the workshop coordinator for 240 Tutoring, and I'm here live today with you to look at some math from the GK exam. So today we're going to be looking at competency 2, skill 4 specifically, and we'll get into that in just a second. But I'm here live in our Facebook group for Florida every Tuesday at 10 o'clock Central or 11 o'clock Central Standard Time, 12 o'clock if you're a little bit further east. So I'm glad you're here with us if you're able to join us live. If not, this video will stay right here in this Facebook group. You can find it in the feed, or you can click on videos and you'll find it there after it has a chance to save. We also upload these to our YouTube channel. So if you are more of a YouTube fan, you can check them out there. But we're going to go ahead and get started and do some math today because we've got some tough math to do today. So let's jump right in. I'm going to share my screen with you. So give me just a second to get that going. You should see my PowerPoint. All right. So here we go. Last week we looked at, and it appears as if my camera might be frozen. So I'm hoping you can still hear me. I'm going to stop the share and try to reshare and see if that unfreezes the camera. Bear with me for just a second. Okay, I think we've got that back. All right. Technology is always fun. Okay. Try that one more time. Okay. Are we moving? Yes. Okay, so again, we are looking at competency 2, skill 4. Last week, we looked at skills 1 through 3, and I saved 4 because the problems or the questions associated with this skill are much more difficult and time-consuming than the ones we looked at last week. So I wanted to save those and talk about them separately. I'm going to try to watch the comments. The internet is a little bit lagging here where I am, so if you have a comment, if you have a question, post it there. I'm going to manually check it instead of waiting for it to pop up just to make sure I don't miss anybody's question. But these are some challenging problems. So if I lose you or I'm going too fast, let me know. I'll gladly slow down or I'll go back to something if you need me to explain it again. So we're going to look specifically at those competencies, and then I'm going to teach you some skills and maybe give you some strategies to help you tackle these more difficult questions. So again, today we're looking at skill 4 of competency 2. So competency 2 is geometry and measurement, and this is solving real-world problems using geometry and measurement, including unit conversions. And they love to combine all that stuff to give you multiple steps to deal with. So we're going to talk about that, and I'm going to walk you through it. Again, if you have a question, these are harder. Don't be shy. Ask. I want to help you. So let's tackle this first question. All these questions are coming from the FTCE website, where you can find the free and public questions that are practice, but they don't give you explanations to those. So that's what I'm here to do today, is to explain to you how to work these. And we're going to warm up with a little bit of an easy one. And this is number 14, and we're looking at area with conversions. So it says, how many square yards of carpet are needed to completely cover a rectangular floor that measures 15 feet by 9 feet? Now, it's asking us for yards, but it gave us the dimensions in feet. So the first thing I'm going to do is make those match. I'm going to go ahead and change those feet to yards so that I'm working with all the same units. If I'm looking for yards, I'd like to be working with yards. You can wait and convert at the end, but if I do it now, it actually makes the numbers smaller and easier to work with. So you have a mathematics chart on this exam that will tell you there are 3 feet in a yard. So if I want to figure out how many yards this is, I'm going to divide 15 by 3. And 15 divided by 3 is 5. So 15 feet is equivalent to 5 yards. 9 divided by 3 is 3. So 9 feet is equivalent to 9 yards. Nice, easy numbers to work with. It said we are dealing with a rectangle that's dimensions are, we've changed it now, 5 yards by 3 yards. And to find the area of a rectangle, we do length times width. And here it's simply 5 times 3 gives you 15. So we get 15 yards is the area of that rectangle. So the answer is B. So I told you, warming up with an easy one. All right, pretty straightforward. The only thing that can mess you up is if you did 15 times 9. If you did that math, 45. Regroup your 4. 9 times 1 is 9, plus 4 is 3. And you said 135. Well, that would be 135 feet. And it's asking you for yards. Okay, so that wouldn't be correct. You could take that 135 and then divide it by 3 like we did up here, and you would still get the correct answer. Well, actually, it would be tricky. So, yes. Anyways, I like to do it this way, but you certainly can convert it another way, okay? So let's move on. Simple, easy to now more difficult. This one requires drawing. This one requires drawing. Now, it says a 3-foot wide deck will be built around a rectangular shaped pool that measures 15 feet by 30 feet. The resulting shape is also rectangular. If the lumber costs $10 per square yard, what is the cost of the wood for the deck? Okay, so again, they're mixing feet and yards. They're asking us for yards. We're buying the lumber in yards. So I'm going to change, again, all of these dimensions to yards. Same principle. There's 3 feet in a yard. So I'm going to go ahead and change this. 15 divided by 3 is 5, so I now have 5 yards. 30 divided by 3 is 10, so I now have 10 yards. Make that 0 a little bit bigger. And I've still got one more over here to work with. 3 foot wide. Well, if it's 3 foot wide, it's 1 yard wide. Now I'm going to draw this. Okay, so I have a rectangular shaped pool. And that pool measures 5 by 10. So 10 here, 5 here. Now I'm putting a deck around it, which will also be rectangular shape. Now this isn't perfect, but you're getting the idea. All right, and we know that that deck, this isn't drawn to scale, obviously, is 1 yard here. And it's another yard here. It's 1 yard wide everywhere around. It's a yard here, a yard here, okay? So if we look at this and we want to figure these dimensions, all right? If this is 10 and this is 1 and this is 1, I now know the length of this side of the deck is 12. 10, 11, 12. If I want to figure this way, I know this length is 5. I also know the deck is 1 here and 1 here. 5 plus 1 is 6, plus 1 more is 7. So I'm going to redraw this just a little bit easier to see. So I have my pool that's 10 by 5, and I now have my deck. It's a poor drawing that we know is 12 by 7. I'm going to glance at a comment and make sure I'm not losing anybody. I now have my deck. Comments not wanting to show up. Here we go. Hold on. We know is 12 by 7. Okay. No comment showing, so I think we're in good shape. Comments not wanting to show up. Okay. So if you have a comment, I can't see it at this moment. It's been a little laggy, so I'll check it again in just a second. So I've got my new sketch to work with here. And it says, I'm looking for how much lumber for just this deck. Okay, so I'm going to figure out what would the area of the pool be. So the area of the pool, it's a rectangle. So we do 5 times 10 gives us 50. Now we know the total dimensions of the deck and the pool, not just the deck, but the deck and the pool is 12 by 7. Well, if I do 12 times 7, I'm going to get 84 for the whole thing. So if I know this whole area is 84 and I know this piece in the middle is 50, I can subtract to find just how much is the deck. So I'm going to do 84 minus 50 and I get 34. Now you might be thinking, I'm done, right? Not quite. It says the lumber costs $10 per square yard. So if I need 34 square yards, I'm gonna have to do that times 10 to figure out the total cost, and I'm going to get $340. So the correct answer here is C. So I think what's critical to this one is really drawing the picture. Drawing the picture is super helpful. Let's see if I can see my comment now. I'm going to get $340. So the correct answer. I'll turn that volume down. I'm still not seeing a comment. It shows there's a comment, but it's not letting me see it. So if you have a comment, please try again, submit it again, and I'll see if I can see it. Try to help you out there. But again, this question is really about drawing the picture. It's about drawing the picture. So I hope that helps. This one might take you a minute to go back and digest. Just know there are multiple ways to solve a lot of these problems. I'm just showing you the simplest thing that works for me. Okay, so I like to convert those numbers to make them easier to work with. You could wait and convert them later. This is just the method I choose. But once you understand the thinking behind it, the math can occur a couple of ways. So let's look at the next one. This one's surface area. So it says a teacher covered the exterior of a rectangular prism-shaped box. So we're looking at the exterior, the outside of a rectangular prism-shaped box that measured 8 inches by 9 inches by 10 inches using one sheet of rectangular-shaped wrapping paper that measured 2 feet by 3 feet. There were no gaps of overlapping paper. How many square inches of wrapping paper were left over? So I'm going to say that again. How many square inches of wrapping paper were left over? Okay, so we're going to actually work this out. So I'm going to start with changing all of these to the same unit. Now, last time I changed the smallest unit to the largest unit, and I'm going to tell you why I'm not doing that this time. Because if you look at your measurement or your reference chart, it'll tell you there are 12 inches in a foot. I can't change these to feet without making them fractions or decimals. And that's actually going to make the math harder. So I'm going to do the opposite of what I did before. And I'm going to go with the easier math. I'm going to change these feet into 12 inches. All right, or into inches. So if 12 inches is 1 foot, 2 feet, 2 times 12 would be 24 inches. 3 times 12 would be 36 inches. So I'm just getting these all in the same units of measurement, all in the same units of measurement. Now I'm going to draw this and actually work with it. It said we were looking at a rectangular prism. Now I'm going to draw a rectangular prism. You can draw yours differently from me, and that's totally fine. I remember when I was young and I learned how to draw a three-dimensional shape, I thought it was the coolest thing when my teacher taught me. So if you want to be that cool teacher in the future, teach your kids how to draw three-dimensional figures, okay? Now I'm going to label this. It said that measured 8 by 9 by 10. So I'm going to say this is 8 this is 9, and the height is 10. Of course, I didn't draw that to scale, but you get the idea. 8 inches, 9 inches, 10 inches. And we're wrapping this with wrapping paper. So we're not looking for the inside. So we're not going to use a volume. We're not going to use a volume. We're going to use surface area. Now, if you look at your reference chart, it tells you surface area equals the sum of the area of the bases and its wrap. So all the wrap in between. Now, you could do this with a little bit more complex math, but I'm going to show you just the easy way to do it. We're looking at, I've got to cover all of these shapes. And so I need to know the area of all of them. I'm going to start with the top and the bottom. So this one down here and this one on top, because they are the same or equal. All right, so to find the area of that rectangle down there, I would do 8 times 9, and I get 72, okay? And I know there's 2 of those, so I would have to double that 72, 72 times 2, and you get a calculator, so you could certainly do this on a calculator. So far, the math hasn't been hard, so I've just been doing it manually. Get 144. So I now know the wrapping paper to cover those 2 would be 144. Now I'm going to take this front piece that's 9 by 10, and it's got the corresponding back piece over here. Well, 9 times 10 is 90, and I have 2 of those, the front and the back. So if I do that times 2, you can pull out your calculator if you'd like, you're going to get 180. Now, I've only dealt with 4 sides, and there are 4 faces. There are 6. I've got 1 more to deal with. I've got this one over here, the ends, and its corresponding one over here. And this one, we know if this side is 10, this height is still 10. So I would have 8 times 10 for this one, which would be 80. And I have 2 of those. 80 times 2 is 160. So to get the total surface area, I just add those up. Now, math got a little bit harder. I don't want to sit there and add all that up. I'm going to pull out my calculator. 144 plus 180 plus 160. And I get 484. So that surface area of that prism is 484. Okay. Now it said we had wrapping paper. See, there's multiple steps here. That was 2 feet by 3 feet. So 24 by 36. I'm not going to do that math either. I'm going to get out my calculator. 24 times 36. So our wrapping paper surface area was 864. So to find how much wrapping paper would be left over, we simply subtract the surface area of the prism we were wrapping from the total wrapping paper we had. So 864 minus 484, you can plug that in your calculator, 380 inches were left over. B is correct. All right, so 380 square inches, I should have squared, square inches were left over. So again, this isn't difficult, it's time consuming, and you have to have an understanding of surface area and know some basic formulas. Okay, so now we're going to move on to the hardest one. All right, so we did a little bit of area, a little bit more area, then we did surface area. Now we're going to look at volume. Okay. It says a building contractor needs to compute the volume of air contained in a building with a rectangular floor as shown in the figure below. The building is 20 feet long, 4 yards wide, 9.5 feet on 2 sides, and 15 feet from the floor to the peak. What is the volume of air in the building in cubic feet? Now, the first thing you need to know is that volume is the amount of space something takes up. So the air is contained inside this building. So how much space is in that building? You think of how much water it would hold, right? So we're going to be finding volume. First of all, you had to know this was volume, and it tells you in there, volume of the air. You can go to that math reference chart and see the formulas for volume. And we'll look at that before we close out our video today. But the first thing I'm going to do is I'm going to get all these units of measurement the same, because it's too difficult to work with this way. So I have a fraction, which I'm going to change into a decimal just because that's going to be easier to work with. And then I have yards over here. All the rest are in feet. So I'm going to go ahead and change, instead of changing all the feet to yards, I'm going to change the 1 yard measurement to feet. There are 3 feet in a yard. So if I have 4 yards, 4 times 3 is 12. So I'm just going to label this as 12 feet. Now, to find the volume, if you go look at that reference chart, it's not going to tell you how to find the volume of a building shaped like this. It's going to tell you basic prisms and pyramids. So we're basically going to have to deconstruct this building into 2 regular 3D solids. So I'm going to take this apart. And basically what I'm going to do is separate this into a triangular prism. And I'm going to redraw it. Again, be the cool teacher who teaches kids how to draw it. That's not the best drawing. And then I have a rectangular prism that I'm going to draw. And I'm going to label. Okay. So now I know this is 12, I know this is 20, and I know this is 9.5. Okay. I know the dimensions of this. The triangle, on the other hand, I only know that if the bottom right here of this rectangle is 20, the bottom of this piece of the triangular prism is going to be 20. So I know that measurement. Okay. I don't know this piece, the base of the triangle, or do I? Anybody see it? I'm giving you a second to look. It's going to be this piece, because it's the top of the rectangular prism. It's going to be the same as its bottom edge. All right. So if I have 12 down here, this edge is also going to be 12. Now, something else I'm going to need is the height. To find volume, I've got to have length, width, and height. All right, got to have those things. And I don't know the height of this, but I have enough information to figure it out, because it told me from here to here, this space right here, it gave me that measurement right here, 9.5. And then it told me the whole thing is 15. So if I just want to know this piece right there, that height right there, I can just do 15 minus 9.5. Okay, so I'm going to do 15 minus 9.5. Actually, I got to line up those zeros. Don't be messy like me. Nice, 9.5. There, that's a little more clear. Bring that decimal straight down. I'm going to have to regroup. 14. So I now know the height of my triangle is 5.5. Now I have all the information I need to do the math, okay? Some of you are thinking, oh my goodness, this problem is long. It is. That's why I saved all of these for one video by themselves. Okay, so we're gonna work with the easy rectangular prism first. So if you look on your mathematics reference sheet, it's gonna tell you the formula for volume equals big B, which is area of the base times the height. So when you see this big B, that means area of the base. Whoop. I'm trying to write on the edge of the screen here and it's mad at me for it. So the area of the base times the height. So to find the volume of a prism, we have to figure out the area of the base times the height. Because really when we're looking at it, you've got a whole bunch of those bases stacked up however high it is. So once you find the area of the base, You just got to figure out how many of those are stacked up. How high is that? So we're going to have to figure out the area of the base times the height. Now you could look at this prism a couple of ways. You could look at this piece is the base and find out the area of the base times the height, or you could look at this piece as the base. Either way, I'm going to do 12 times 9.5. Okay, I'm going to do that 12. Remember that 12 is converted. 12 times 9.5. And I get, sorry, my screen just went weird on my end. All right. I'm going to put that in again. 12 times 9.5 gives me 114. And then I'm going to multiply it by my height of 20. So times 20. So basically I did area of the base, 12 times 9.5 times the height, which is 20. And I just put that all in the calculator. And it's not wanting to cooperate with me. Times 20. And I get 2,280. Okay, so there is the volume of my rectangular prism. Now I've got to find the volume of the triangular prism. All right, so for triangles, if you look at your math reference sheet, it's going to tell you volume equals area of the base times the height. Well, to find the area of a triangle, we've got 1/2 base times height. And then we've got times the height of the whole prism. So we've got that formula for the area of the triangle times the height of the prism. So now I'm going to move over here where I have a little more room. I'm going to have 1/2 times the base times the height of this triangle. So I have 12 times 5.5. All right, so I'm going to do that on my calculator. 12 times 5.5 equals 66. And I'm going to take 1/2 of that 66. So I'm going to divide it by 2. And I get 33. All right. That tells me this. Now I've got to do times the height of the whole prism, which was 20. So if I do 33 times 20, I'm going to get 660. Not done yet. Not done yet. Now, if we want to know the volume of this entire building, we add our two volumes of our two dissected pieces together. So I'm going to do 660 plus 2,280. And I get 2,940. So the correct answer here is C, 2,940. Now notice, if you had stopped with here, it would have been tempting to choose this answer because it's so close. It's so close. So here it's really about your persistence to do the whole problem. Now I want to talk to you about these kinds of problems. So when you see I've got to do volume of two different things, I'm going to add those volumes together, I've got to convert units. If we go back to this one, I've got to convert units, I've got to figure all this stuff out. These types of problems take time. Here's going to be my recommendation to you on your test. When you run into these kind of problems, flag them. Flag them. If you have taken practice tests and you have been close to running out of time, you saw how long it took me. All right, now I was moving slow and I was talking through it and I was doing some math I probably could have done mentally. But those two problems took me a good 5-6 minutes each. And I have a great math background, okay? If you struggle with finishing on time, please don't stop and spend 10 minutes on these problems. Please don't. Flag them, keep moving, do all the ones you can do a little bit faster and come back to them. Like as soon as I read this problem, I went, oh, I'm gonna need some paper. When I read this problem, I was like, okay, I'm gonna need a clean whole sheet of paper. I mean, look how much trouble I had even just getting all the work on this slide on this screen. So the biggest piece of advice I can give you with these types of problems is if this is difficult for you, please flag it and come back to it. Come back to it. Do not spend 15 minutes on this problem when you could have gotten 5 or 6 others right in the same 15 minutes. And then you don't get to those 5 or 6 problems at the end because you've run out of time. So that would be my biggest recommendation to you. Please remember that you need to know your test format, know your time limits, know what the screen looks like, know how to use the on-screen calculator. I'm using just a basic calculator in front of me, but you need to practice using that on-screen calculator. Go in and request that and look at it. Go in and do some practice questions to see what the screen looks like and practice your pacing. I would highly recommend you get really familiar with this where you can quickly find things like here, the area of the triangle. I needed this formula today. I needed the area of a rectangle. I needed the surface area. I needed to know the surface area of a prism or pyramid equals the sum of all the areas of the faces. I needed to know that. I needed to know the volume. I needed to know that that big B stood for area of the base. You might come across one that's a pyramid or a cone. And the faster you can find these things on the chart, the faster you'll be able to move. It also has these conversions. We certainly needed these today, yards to feet to inches, all of those things. That's super helpful. They're giving you that tool. Use that tool. You don't have to memorize these formulas. Guys, you're lucky in other states. Sometimes in other states, they don't get to use a formula chart. And so they have to memorize those. You have this chart, use it. They're giving you a heads up. They give you some hard problems, some very hard problems, but they're giving you a reference sheet to help you with solving those problems. So use that as you practice. Get used to referring back to that to see if it improves your speed. Now, if you'd like more information, I highly recommend, if you want some more study materials, to check out our study guides. We have free resources on our webpage. Again, this video will stay right here in our Facebook group. You can check it out anytime. We also upload those to YouTube. So if you are not seeing this live, you have time to watch it. You can comment on Wednesdays. So every Tuesday I do a live video. Every Wednesday I do live office hours where I'm just active in our Facebook group. So if you have any questions, please go ahead and post those in the comments. Even if you're seeing this a day later, 2 weeks later, you'd be surprised how far back I can get during that time and answer questions. So put that in the comments and I will gladly come back and help you. I hope you found this video helpful. We're going to move on to the next competency next week. So I hope to see you there for that. And again, I'm Dr. Christy Mulkey with 240 Tutoring, and I wish you all the best. Thank you and see you next week.